So our use case is use case 9, which covers autonomous train operation. Right now the railway industry is moving towards full automation, even if there is a high level of automation in this sector. And in order to achieve that, there is a need for environment perception. And this is, as you can imagine, this involves some safety-related functions. So some of them, such as, for example, light signaling detection, needs artificial intelligence-based systems. And in order to train and verify and validate these systems, we are using real data right now, but this is extremely time-consuming, and therefore we are trying to make it with synthetic data, which will have several advantages, and that is our main focus of our use case. So first you would need to generate the scenario where you can record the video sequences for validating and verifying the AI-based environment perception systems. So in order to generate this scenario, we are utilizing a simulator which is called Train Simulator. It is actually a video game, and right now it covers what we need, but we could move to other kind of simulation engines in the future. Once we have this simulation engine, we need a way to gather the different frames that we are considering, to label them. Then we have to label them, of course, and once they are labeled, the other need is to change the video sequence that we have, for example, to other kind of dimensions of the so-called operational design domain, which means changing the weather conditions or the lighting conditions, for example, so that we can recycle the labels that we generated in the first place. So that would be the main needs. The environment generation, virtual simulation from the environment, gathering frames, suitable frames, labeling them, and then, of course, executing the evaluation, the testing and the validation verification methodologies to assess the system that we developed for environment perception. Okay, so since it is a project focused in validation and verification, and this is our main purpose, all the methodologies that have been covered here are really suitable for our concrete use case, and so we are basically trying to adapt them to the railway domain and to our concrete simulation engine. And right now the results that we got are quite satisfactory, at least from the verification and validation point of view. We saw that we would have to improve our artificial intelligence-based systems because they are not working as well as expected with virtual data because of the so-called domain adaptation gap. But so the Values project showed that we have work to do in this direction, and that we have an alternative way to validate and verify these systems, which is not as time-consuming as the real data would be, in essence, in a nutshell. So let me share my screen. Now you should be able to see it. Here you can see one of the images that we were able to extract from Train Simulator, which is the tool that we used. It is true that Train Simulator is not a tool specifically thought for autonomous vehicles. In fact, it is a video game, but we wanted to take advantage of the very good 3D scenarios that are already available here, and that is the reason why we went for this tool. So our idea in Values was to recreate the same journeys against different different weather conditions in a way that we could capture
the frames of the resulting video sequences belonging to the same timestamp, and thanks to that we would have the same frames or the same scenes under different weather conditions. So the main idea why we went for this approach is that now we can label just one of the frames. For example, here we would draw the bounding box around the sign containing the number 4 here, and then we could reutilize this label for the rest of the frames, because the position of the sign remains in the same pixel coordinates. So this is a way to generate data in a semi-automatic manner. It is semi-automatic because at least you need to label one of the frames, but of course you save a lot of time anyway. So a part of doing this, we also utilized the 3D editing tool of values, which is the one that of values, sorry, of Train Simulator, which is the one that you can see here, to make some occlusions, or to create some occlusions for the target signs and signals. So here, for example, we managed to occlude this sign here with a little tree next to the railroad. So having shared how we generate the data, let me now share some of the inferences made by our sign and signal detection system. So this system, or this AI model within the system, was not trained with synthetic data, only with real data. But even that, you can see that the results are quite good with synthetic data. Here, for example, we can see a mismatch. The model is being confused and stating that this clock here is a sign, so that would be a false positive. But in overall, the results are pretty impressive, and this shows that the system is not only able to bridge the gap between real and synthetic data, but it is also robust enough to work under the different weather conditions that we generated here. And regarding the last image here with the occluded sign, we can see that the system, or the model, the AI model, was not robust under these occlusions, because you can see that the sign here is not being detected. So this was a summary of the work that we have been doing in values. So hope you enjoyed this demo, and see you next time.